All right, what's the chance that in the first turn, all 5 dice show different numbers? I don't know. I just make up the questions. I don't know the answers. OK, so how can we think about figuring out what the outcome is? What has to happen to get 5 different numbers on the 5 dice? How many numbers is it possible to get? 6, right? There's 6 numbers to choose from. Yes? OK? Every dice is going to show some number. Right? OK. So from the 6 possible numbers, we need to pick 5. Right? And those 5 might be, for example, 1, 2, 3, 4, 5. It might be 6 that gets left out. Yep. But now, that's just saying we rolled. This is saying 1, 2, 3, 4, 5, but that 1, 2, 3, 4, 5 could be in a bunch of different orders. Could be 2, 1, 3, 4, 5. Could be 5, 4, 3, 2, 1, whatever. So we're thinking that we need to say the first die gets some number from 1 to 6. This is saying the first die got number 1. Second die gets some number from 1 to 6. We're saying the second die showed 2 spots on top, et cetera. OK? So how many ways are there of assigning these 5 numbers to the 5 different dice that we rolled? 5 factorial, right? OK? So what we've got now is, for any particular set of 5 numbers, there's 5 factorial orders that they could be in. If we're assigning one of those numbers to each of the dice in sequence, thinking about rolling. OK, so now we've got 5 factorial times 6 choose 5. What's 6 choose 5? 6, right? You're just picking which one to leave out. Yep. What's 6 times 5 factorial? 6 factorial, yes? OK, so we've got 6 factorial ways of picking 5 of the 6 things and then putting them in some order. So these are the number of ways that we can satisfy the restriction that we get one of each number, that we don't get any repeats, that the 5 numbers are distinct. How many different things could happen in all? Well, there's 6 choices for what the first die gets, and 6 for what the second die gets, and 6 for what the third die gets, et cetera. And are all those, so there's 6 times 6 times 6 times 6 times 6 is 6 to the 5th different possibilities. Are those equally likely? Yeah, right? Because by assumption the die is fair, the die rolls are independent. There's no, every one of those 6 to the 5th possibilities is equally likely. So that's this over 6 to the 5th. And that gets rid of one of the 6's again, 5 factorial over 6 to the 4th. And you could work out what that is.